Hi guys, and welcome to the second lecture for Chapter 6. Now that we've gone over demographics and demography, we're going to introduce you to human population dynamics. Let's take a look. So we have a lot of people on the planet. Currently we have over 7 billion people on the planet, and we are steadily approaching 8 million actually. And just to put into perspective just how large that number is, let's do a quick little bit of math. If you were to start right now and count to 1 billion, it would, counting at 1 per second, it would take you about 31 years to get there. Counting to 7 billion people would take 221 years. So this is a huge number of people that the planet is currently supporting. And the reality is that populations are continuing to grow. We are on track to hit 8 billion people here pretty soon. And it's also going to be useful to understand where most of the growth in human global populations are occurring. And most of this growth in human populations occur in impoverished countries. It's going to be in places like India and in Africa, and particularly in sub-Saharan Africa. So now that we have an idea of what the 7 billion people actually looks like around the planet, we have an idea of the scale of that number, let's shift our focus just a little bit to human population growth rates globally. Now, while our populations grow at around 80 million people each year currently, that hasn't always been the case. Take a look at the graphs over on the right-hand side of your screen, and you will see that our growth rates have dramatically increased in the last 200 years or so. Now, this is indicative of what's called an exponential growth rate. Think about it this way. From 10,000 BC all the way to 1800, 12,000 years, that's how long it took our populations to reach 1 billion people. However, in the last 200 years, we dramatically ramped that up and actually added another 5 billion people to where around 2000, we then had 6 billion people on the planet. So even there, you can see how much faster we are growing in population. But it gets even scarier. 12 years after 2000, we added our 7th billionth person to the population. So while it took 12,000 years to reach our first billion people, it only took 12 years to add 1 billion people to reach 7 billion people from 6 billion people. So we went from generating 1 billion people every 12,000 years to generating 1 billion people every 12 years. That is insane. And again, exponential growth rates are not sustainable. Eventually, we're going to hit a carrying capacity. If we're smart about it, we can taper off our populations before they hit the carrying capacity, but far more likely carrying capacities are overshot and then the population crashes. And we're going to look into some of the consequences of exponential or runaway human population growth and what that might entail for us in the future. Now again, what I'm trying to get across is that when it comes to population growth rates around the world, it's again not evenly distributed. A lot of places aren't growing very much at all. Recall how in the previous lecture we went over how different countries have pretty variable growth rates depending on their age structure diagrams. Well, in a lot of the industrialized world, the population growth rate actually is pretty close to zero. However, in countries that are developing and typically pretty impoverished, are going to have very, very high population growth rates. The highest rates of population growth in any part of the world is going to be in the middle of Africa. So here we have a few of the causes and consequences of human population growth, what is primarily driving human population growth, as well as some of the consequences if we really don't change our ways in terms of how many people we are currently producing per year. And we're going to first look at the causes and then look at the consequences separately. So let's take a look. So the reason we are growing so rapidly, and again we touched on this in chapter 1, is a combination of a decrease in the death rate while we kept our birth rates pretty high. And remember how we talked about in chapter 3 as well as in the previous lecture that all else equal, excluding immigration and emigration, because again this is a global population, if the death rate is below or lower than the birth rate, the population globally is going to increase. So this decline in the death rate is due to a few different reasons. First is that more agricultural production equals more food. If there's more food to go around, that means that there is less starvation. And the two things that really led to the increase in the availability of food is going to be the agricultural revolution way back in around 10,000 BC, and then more recently the industrial revolution and the green revolution, something that we will go into in detail in chapter 7. In addition to increases in the availability of food, we also got better medicine and better sanitation. So now not only are people no longer starving to death, they're also not dying of disease or poor health conditions. So for all of these reasons, the death rate globally began to decline. So while the death rate was declining, we still had a pretty high birth rate. Now, keep in mind that originally this wasn't a big deal. If we had a pretty high death rate, we needed a high birth rate to compensate and balance out the population. With a high birth rate and a high death rate, and when they're approximately equal to one another, that means that the scale isn't tipped in either way. However, with a decline in the death rate and the birth rate still being pretty high, that means that the population is going to increase pretty dramatically. Again, now things are off balance. We have a birth rate that is far higher than the death rate. And the reasons that we still have a pretty high birth rate are for a few different factors. The first is the lack of contraception and sexual education. It's no surprise that the impoverished and developing countries, the countries with the highest population growth rates right now, are going to be those that don't have readily available access to contraceptives, and they don't have a very good sexual education program. In addition, even once fertility rates begin to go down, populations that were previously growing rapidly will continue to grow due to something called demographic momentum. Demographic momentum is basically the tendency of populations that were growing very quickly to continue to grow quickly after their total fertility rate has begun to drop because of the distribution of their young, the number of individuals in their population that are pretty young. Again, this is going to be reflective of those age structure diagrams that we talked about in the previous lecture. So what I want you to take away from this slide is that for a number of reasons, food, sanitation, and medicine, the death rate went down. However, we already had a high birth rate, and it stayed high because of lack of contraception, lack of sexual education, and demographic momentum. Because the birth rate is now higher than the death rate, things are off balance and the population is growing rapidly. Now that we've taken a look at some of the causes, let's look at the consequences of this continued population growth. Now, continued high population growth rates means that we're going to have more and more and more people, and that has a number of very specific consequences. First off are increases in resource use. More people means that we're going to need to produce more food, we're going to need to produce more stuff, more goods and specific resources, we're going to need more homes, more fossil fuel use, and more waste, and specifically more pollution, especially with current practices until we get some of our waste usage under control. The problem here, again, something that we will refer back to again and again and again, is that the earth is finite. There is a limited amount of space for growing food, there is a limited amount of space for housing people, there is a limited amount of non-renewable resources such as fossil fuels or specific minerals, and there are a limited amount of exhaustible renewable resources if our consumption practices are higher than the ability of natural ecosystems to replace those exhaustible renewable resources. Those are going to be things like clean air and clean water if we either pollute the air or we use up the clean water faster than it can actually be replaced. And these problems lead to both environmental degradation as well as long-term social and political as well as economic issues. We're going to see, if we continue down this route, we're going to see huge losses in economics, so a lot of loss in money for different countries. There are going to be huge health impacts as we deplete specifically resources such as clean water and clean air, as well as huge impacts in human health. If we begin to run out of food, we begin to use up and deplete the earth's soil, and therefore the ability for the earth to provide nutrients and food for the global populace, as well as social disruption. When we begin to run out of these resources, it's very likely, as it has been in the past, whenever you look in human history, a lot of conflict is going to be due to lack of available resources. When we begin to reach the limit of the earth to provide specific resources, people are going to be fighting for what's left. impact, and that can get really nasty really quickly. For reference, look at any dystopian movie ever, or look back in history and see what happened and how violently people fought over resources before the Industrial Revolution, when they became more readily available. And when we look at human consequences, and specifically human impacts on the environment, we cannot look at population alone. And this is because impacts to the environment are both a function of the number of people in that population, as well as the ecological footprint of a given individual in that population. Refer back to chapter 1 when we were looking at the different ecological footprints of different countries, and note that it wasn't directly or necessarily a function of the number of people in that country, but the number of people multiplied by the average ecological footprint of a person in that country. And that leads us to something known as affluence, which we will get into in just a second. For now, when we look at the impact of a given population or entity on the environment, we usually refer to something called the IPAT model. In the IPAT model, I, the impact of a given population or a given entity on the environment, is going to be a function of the P, population, A, affluence, and T, technology. Now, population is pretty simple. We've defined that already. That's the total number of individuals in whatever entity that we are looking at. Remember that every individual needs a certain number of a certain amount of space and resources, and so all else equal, the more people in a population, the greater the impact on the environment. But it's not population alone. It is population multiplied by a term known as affluence. Affluence is the per capita resource use, the average ecological footprint of a person in that population. Basically, this is a measure of, on average, how much of a given resource or resources a person uses. So if a country has a very low affluence, the average ecological footprint of a person in that country is going to be very small. Think back to like Indonesia when we looked at our ecological footprints around the globe. Now, an area with a population with a very high affluence means that on average, every person in that population has a very large ecological footprint. For an example of that, look at either the United States or look at industrialized countries such as China. So how the average affluence of a population multiplied by the number of people in a population are really going to determine the impact on of that population on the environment. However, this is also multiplied by the term technology. Technology is basically the level of technological advancement of that population, and this can increase the use of resources or it can decrease the use of resources depending on how technology is used. Traditionally, technology tends to increase the number of resources used by a given population and increase affluence, and this is because technology has traditionally been increasing our ability to extract resources quickly and use them up faster. So technology historically has increased our affluence and has increased the impact of a population on the environment. However, more recently, technology, as we have begun to invest in renewable energy sources, for example, or decreasing our waste production, technology has begun to decrease the affluence of any given population because it is beginning to be used to mitigate our effects on the environment. So technology is kind of a mixed bag. It increases our ability to extract resources, but it may also be used to offset some of the damage we do on environments. In addition, there is a fifth term in the IPAT model that we really haven't gone over. It's not really incorporated very much into a model right now, and that is a term known as sensitivity. This fourth term shows how sensitive an area is to human pressure. An area like a desert might be able to take a lot of abuse because it doesn't have a lot of biological activity. It's a pretty extreme environment, and therefore any impacts to it will be pretty minimal. However, areas that are very biologically productive, such as tropical rainforests, might be very sensitive to human impacts, and so that impact term is going to also be multiplied by the sensitivity of the ecosystem that we are actually looking at. So please understand the IPAT model. It will be asked on your exam, but that is everything I have for you guys today. Tomorrow, and for the final lecture, we will be looking at total fertility rates around the world and the demographic transition model. I'll see you guys then. Bye-bye.